All right, so going along with what we did yesterday, what would be the easiest way to multiply 3 times 4 and 1/10?
Take out the decimal.
You could take out the decimal, that's one way. What's another way?
Round. No.
Yeah, but we're not going to round on this activity. Could you multiply across? Yeah. You could do 3 times 1
3.
and 3 times 4, then put your decimal back in, right? What do we learn about these tens here?
They don't matter.
They don't matter if they cancel each other out. If they have opposite operations like multiplication, division, or addition, subtraction, and they're the same digits, they cancel each other out. How does a 1 change my answer when I'm multiplying?
It doesn't.
It doesn't. So when you are in algebra and algebra 2 and possibly even 7th and 8th grade, Cooper, you'll have to ask your mom about this, but you might be looking for ways to simplify equations. And these are ways you can simplify equations. You could look for ones. You can look for numbers that cancel each other out. So this is leading you up to the next step, okay? Let's take a look at, let's go down, all right? 3 times 4 is 12. How is this one different?
Because it's 17.
And 6/10 instead of, what number did we have?
10.
Does it still cancel?
Yes.
It does. So, and this one also has a 1 that does not change your answer when you're multiplying. Okay? Take a look at this one. Cooper, what's the best way to multiply 3 times 2 and 4/10?
1.2 plus 6. So 3 times 4/10.
Okay, so he says 3
Or
times
24.
4/10.
I just pretty much simplified it.
3 times 4/10 and 3 times 2. Right? You could do 24 times 3. In my mind, that's easier. What's 24 times 3?
72.
72. I knew it was somewhere near 75 because that would be 25 times 3. So 72, where do I put the decimal?
Between the two.
Okay, and then same thing here. Do we have any answers that are different?
No.
Okay, let's take a look at the problem for today. So Mr. Moore, he wants to build a rectangular patio using concrete. Oh, by the way, this is a 4th grade problem exactly. We just changed a number to include a decimal. But otherwise, you've done this probably feel like 100 times, okay? So think of it as something that's not too hard for you. So Mr. Moore wants to build a rectangular patio using concrete tiles that are 12 square inches. By the way, I put 12 square inches on the floor for you.
It's a square.
It's a square, all right. The patio will measure 13.5 feet by 43 feet. What is the area of the patio? How many concrete tiles will he need to complete the patio? Okay, so if you were in 4th grade, what would you draw? A tape diagram or an area model? Most definitely. I would think of this as my patio, though. It's not really an area model, is it? It's just pretty much a rectangle. And when we, go ahead, get busy drawing. And when we label this, it would be 43 feet by 13.5 feet, correct? And then you might even do this, length times width equals area down below. Is this all coming back to you now?
Yes.
Okay. All right. So the only thing different about 5th grade is that we've got a decimal in one of the numbers. Okay. So yesterday we learned, let's just take the decimal out. Let's make it unit form. And then we'll put the decimal back in and change it to standard form. So how would I write a problem when I just take the decimal out? Caden?
135 times 43.
Okay, you're almost right. 135 what?
Tenths.
Very good. 135 tenths times 43. So this is reviewing yesterday's lesson. Go ahead and work that problem. Okay, now just a minute. I don't want anybody saying the answer because not everyone works at the same speed. But I'll get back to you on what you were getting ready to say because I think I know what it is.
I know what it is.
So, and then in 4th grade, we might have went ahead and written area equals and then put the answer, okay? So, where will I decide to place the decimal, Brian?
Between the 0 and the 5.
And why did you choose that placement?
Because it says on the 10th.
Good. The tenths is 1 decimal place value, isn't it? So, the total area of the patio would be 580.5 square feet, correct? And here's how you might possibly write it. We can also do feet squared. You don't have room for the other. Okay? So my question here is, if the tiles are 12 square inches, how many tiles will he have to buy?
500 square inches each, that is.
So Aubrey says 580.5. Problem here. Now, Aubrey, I like how you did that. So she, in her head, she already transferred this from 12 square inches to 1 square foot. So that was great. How many of the rest of you already had that figured out? This was 1 square foot. Just a minute. I'll get to that. So good job, okay? But when I go to Home Depot, they're not going to sell me a half a tile. That's the problem.
Buy a whole extra one.
And then cut it in half. So what do you think, how many tiles will we need, boys and girls? 581 tiles. And if I were writing a sentence, I could put it in a sentence, but I'm not going to take time for that right now. How do you spell tiles, Mrs. Lewis? My goodness. There we go. Okay, so good job. That's kind of a review of 4th grade area. Okay, with a 5th grade twist. Okay, let's take a look at your lesson today. Now, starting today, I need everyone to listen to me. This is very important. The only time you need to draw the area model is when you need it. Now, that's going to vary, isn't it? I like to be able to check my answer with the partial product. So I might draw it more than Rustin, who just wants to get it finished quickly. Speeding ticket, right? Okay, so yeah, he got one. Next week we're doing our math test, Rustin, so I'm on top of this. Okay, so I don't feel like I'm going to need the area model on this one because I'm multiplying 3 digits by 2 digits and it's quite simple, okay? When you get to your assignment tomorrow or you're on Zern, you might decide you want an area model and that's your choice, okay? This area model we're not going to do, but I'm going to label it so you can see how to label it. You do not have to write it, okay? All right, so how is this problem different than the one we just did? I think it was 13.5 times 43 or something like that.
Yeah, it was.
Okay, so how's this one different? Mia, how's this problem different?
It has the, what's it called, the decimal, it's between the hundreds and the tens.
Okay, well actually it's between the ones and the
Oh.
tenths. But what do we have?
Hundreds.
Good, we have hundreds This place value is the hundredths place. So it's 2 place values over from the decimal. Remember that? Okay. So how will I write, well, first of all, let's round it. So I still want to round it to the nearest whole number, if I can. So Alondra, will this be 7 or 8? Now be careful, they're trying to trick you. I'm still going to look at the tens place. It's going to be 7. So now I know your estimating is up at the top, so write 7. Jarrett, what will you round 41 to?
40.
And what's 7 times 4?
28.
Add a 0. Good. And what place value is this? Ones. Okay. So Cooper, I'm going to need you to quit doing that. That's messing with my OCD.
Sorry.
That's okay.
I'm OCD because it needs to be.
I know. Okay. So how will I write this on the standard algorithm now? 738
times 41.
times 41. But what word do I?
100.
Good. So 738 hundredths. Aren't you glad we have an abbreviation?
Yep.
Times 41. So go ahead and, oh wait, I wanted to show you how to label the area model on this. It's not much different. You would just do 738, and then what word are you going to write here? Hunts. Hunts. Hunts ketchup. That's how you would label it, but we're not going to do it. So go ahead and do the standard algorithm. And our answer is going to be somewhere near 280. Do you think it's going to be more or less?
More.
Why do you say more?
Less. Because I already did the problem.
Well, what would be a good prediction? More. Why?
Because we took away the 1 and we took away the 38.
Did we round up or down?
Down.
Okay.
Yep, then way down. Yep.
Okay, now,
That's in the blank blanks.
now are you going to keep talking, or what's going to happen here?
I'm sorry.
Okay. So I got 330,158 hundredths. And equals. Now, can I put the decimal in this number, or do I have to rewrite it in standard form?
Rewrite it.
Rewrite it in standard form. So, where's the only logical place to put the decimal? Alondra, where's the only logical place to put the decimal? Now, I can use Jaden's strategy. She said I just look at the number, the factor, with the decimal, and then I just use that many place values in my answer. So where's the only logical place to put the decimal? Between the 1 and the 5. Is 301 somewhere near 280? Yeah, it is. It is. Okay. Now, just a minute.
That looks wrong. The 4 would be a 5 because it would be 12 then plus the 3. Yeah,
The 4 would be a 5. It doesn't look right, does it?
No, I've got no clue how you did that.
Oh, because I only added 2 instead of 3. So it's 302, right?
Yeah.
Thank you for being so polite. Okay. I hate it when I mess up my video, though. So it's 302. It's not much further away from 280, is it? Okay. So here's your reminder. Okay, and I think I've said this many times. But when I'm multiplying or dividing times a whole number and a decimal, my decimal place value does not change. So if I start with hundredths, what do I end with? Let's take a look at the next problem. I'm not gonna, I'm recording, okay?
Can we pause?
And Amy, Justin, and Robert, I am very sorry for making a mistake on that last problem. But you have a very good group of students here with you. I wonder if they're going to listen. Most kids don't listen, they just write down the answers. Okay, take a look at the next one. Let's start with estimating, okay? So 8 and 2600ths. Well, what would I do here? It's either going to be 8 or 9, correct?
It's 8.
Why do you say it's 8?
Because it's 2.
Because you have to look at the 2.
Yeah.
Very good. So 8 times, now I don't know 8 times 130. So what if I round that to the nearest 100? Would that be easiest? Well, not really. I mean, we'll get to that harder rounding later. But for now, I think it'd be safe to say that our answer will be somewhere near 800. Okay? Somewhere between 500 and 1,000. Is our answer going to be more or less than the estimate? Probably more. Why?
Because we wrote it down. Because the numbers.
Because we rounded down. Good. Okay, I'm going to get rid of this. No, I think I'm going to keep the area model. You better draw an area model. This is a pretty difficult problem. Well, just do it for me one time.
I already started it.
Okay, never mind. Don't draw the area model unless you want to. So how will I write this? How will I write this? I'm really not enjoying this at all. How will I write 8 and 2600ths in unit form? Thank you. Times 128. So here's what I have. Look over here real quick. If I separate 120 and 8, I'm going to have 3 rows of multiplication. The third row has how many zeros? 2. Okay. And this one, I guess you can use the turkey if you want.
I'm not using the turkey, I'm using the reindeer.
Okay, good. Fernando, where would you place the decimal? Okay, and why did you choose that place? It's the hundredths, and that's 2 place values. And what's another reason we should choose it? It's the only reasonable or logical place to put it because we've got an estimate of 800. Now, if you can do this without making errors, then you're probably fine without the area model, okay? If you are struggling and making errors, the area model is one way for you to check your partial products because these 3 would have been what you had, okay? Did I mess up this time? Okay. Okay. So let's take a look at the last problem. This one's a little easier. So, first of all, when I estimate, take a look at that. So I have 82 and 5100ths. Yaneli, is that going to be 82 or 83 for a whole number? And we're looking at the tens place, right? 83. So go ahead and write 83 down. Don't work ahead of me for a minute, please. Okay? And then what's 60 going to round to? 63. 60. But I don't know the answer to 83 times 6, and I don't want to do standard algorithm. So what should I do here?
80 times.
Change it to 80. There's no rule that says I can't round my whole number, is there? So what's 8 times 6?
4,000.
What's 8 times 6? 48.
48.
And how many zeros? So that's ones place, okay? 4,800 ones. Will the actual product be more or less than the estimate? More. Every time it's been more today, hasn't it? Okay, so let's go ahead. Standard algorithm, what am I going to write on the very first line?
8,251.
Okay, go ahead and write that. 8,251 hundredths. Times 63. If you're like me and you don't have room to write standard form beside it, you can always just write it below. How'd you do?
Good.
Okay, boys, that's enough. So, Katie, where's the best place to put the decimal on this one?
Between the 8 and the 13.
Okay, so after the 8. So my answer will be what, Katie?
1,113.
Very good. And if you like to use the underlining strategy, that works pretty well too. Okay? All right.